This point is a negative value because the values of y below the x-axis are negative. So we have the positive c and negative c. This is what we call the y-intercept. These are what we're calling the y-intercept, the points where the line cuts the y-axis. So what's then at the x-intercept? Where the line cuts the x-axis. And so when you're looking at the equation of a straight line, ensure it is in this form. And remember, y and x are variables. They are variables that are coming out of the fact that the equation of the line has to be in terms of x and y, which are the points on the Cartesian plane. So they are components that vary depending with the gradient and the y-axis, and the y-intercept, that is. And so once you are given the equation, if I give you the equation of a straight line, you should be able to determine its gradient by simply looking at the value of m in the equation. So for example, you are told to find the gradient. Find the gradient of lines whose equations are, number 1, with y is equals to 3x minus 4. Y is equals to 3x minus 4. Now, when we talk of the equation being in the form y is equals to mx plus c, this is what it means. That on the left-hand side, we need to see y. And y should have only the coefficient 1, not more than 1. At this point, we need to have the value of x and m. And then we should have the value for c. So you can be able to see the value of x, the coefficient of x here is 3. That is what you are calling the gradient. So the gradient here in this equation is equal to 3. And the value of c is negative 4. That is the y-intercept. Y-intercept is equal to negative 4. So that is how we identify the gradient given the equation. But if they make it a bit different and say, for example, 4x less 2y is equals to 7, you are told to find the gradient of that line. Then you have to start by writing the equation in the form y is equals to mx plus c. So it means then, take the x to the right-hand side. Take the x to the right-hand side. This becomes negative because on the left-hand side is positive. So we have negative. Now we have negative 2y is equals to 7 minus 4x. And then again, we are saying the value of y should only have the coefficient 1. But in this case, the coefficient of y is negative 2. So we divide by negative 2, divide by negative 2, divide by negative 2. This cancel out. So y equal to, now we have 7 divided by negative 2, that's negative 3.5. Then plus, because negative and negative plus, then 2x. So in that case, the gradient here becomes the coefficient of x, which is 2. The gradient is 2. And the y-intercept is equals to negative 3.5. So we shall have found the gradient from the equation. So it is very simple to determine the gradient of a straight line given its equation. What you need to do is rewrite the equation in the form y is equals mx plus c, and then once you've rewritten in that form, then be able to identify the coefficient of x as the gradient, and then the constants become the y-intercept. And we are saying the y-intercept is where the line cuts the y-axis. Hope that is clear now. So that is the second part of our lesson. The third part, as component number 2, is now, how do we get to these equations? Because I've only given you the equation, but you may not know how to get the equations. So again, when you're determining the equations of straight lines, we can't be told to determine the equation of straight lines when you are given the equations or given the gradients, or you are given the 2 points on the line. At any point on the straight line, the gradient remains the same. So however number of points you are going to use on any straight line, you'll find that they will have, or they will give the same gradient as long as they still remain to be the same on the same straight line. So in this case then, we can be able to determine the equation of straight lines given 2 points on the line. That is our next task, determining the equation of straight lines. Case 1, when you're given 2 points on the line. Given 2 points on the line. So how do we determine the equation of a straight line when you're given 2 points on the line? The procedure is very simple. The first thing that you need to do is to determine the gradient of the line. And you determine the gradient using the formula, the change in y over the change in x. After you've determined the gradient, step number 2, you're supposed to take at least one of the given points with a general point xy. Then when you have the 2 points, you obtain what we call the gradient equation. And the gradient equation has to be equated to the given gradient and do cross multiplication to simplify the equation in the form y is equals mx plus c. So in short, what we are saying is, number 1, simply determine the gradient. Determine the gradient. And the gradient we determine it using change in y over change in x. Number 2, use any given point. Use any given point. And a general point xy. And obtain the gradient expression or the gradient function. And then number 3, you equate the gradient expression to the gradient in one above, and cross multiplies to simplify. And cross multiply to simplify. You cross multiply to simplify. So let's do it practically with a question. You are told to determine the gradient. Determine the equation. Let's determine the equation. The equation of a line passing through the following points. And the first set of points is 2, 3, and 5, 8. 2, 3, and 5, 8. So those are the 2 points on the line. So the first task that you do is obtain the gradient using change in y over change in x. So let's do it. Solution, gradient is equals to the change in y over the change in x, which will be 8 less 3 over 5 less 2. 8 less 3, that is 5. 5 less 2, that is 3. So our gradient is 1 and 2 over 3. Once we have the gradient, number 2, use any given point, either this point, you can decide to use either this point or this point, any of them, to determine the gradient. So we'll say we now use the point 2, 3 and a general point x, y, because the equation has to be in terms of x and y. With these two, we'll say gradient will be equal to y less 3 over x less 2. And this gradient expression should be the same as the gradient obtained here, because the points are still on the same straight line. So we equate this one to 5 over 3. We equate that one to 5 over 3 and do the cross multiplication. So now we have 3 into y less 3 equal to 5 into x less 2. Then we expand to simplify. This is 3y less 9 is 5x less 10. Then collect the like terms. Minus 9 to the right hand side becomes positive. So we shall have 3y equal to 5x, then we less 1. Now we divide by 3. Divide by 3, divide by 3, divide by 3. So our equation y is 1 and 2 over 3 of x. We less 1 over 3. And as you can see, the equation has the gradient 1 and 2/3, which is what we got here. So if you determine the equation, you'll still find this gradient is part of the equation. And the y-intercept is now what you're saying is negative 1 over 3. So that is how we determine the equation of a straight line given 2 points on the line. We can do one more example. We can do one more example. And we have this case. We have this case. We have negative 2 and negative 4 and the point 0, 3. Again, step number 1, we obtain the gradient, and the gradient will be equal to change in y over the change in x. And so we have 3 less negative 4 over 0 less negative 2. And this gives us 7 over 2, which is 3.5. Our gradient is 3.5. Number 2, use any given point. And from these 2 points, we can either decide to use this point or this point. So in the first example, I used the first point. Let me try now use this second point. So we now use the point 0, 3 and x, y. With these 2 points again, gradient will be equal to the change in y over the change in x, which is y less 3 over x less 0. And because these points are still on the same straight line, then they will give us the same gradient, which is 3.5. So I'll use 7 over 2 and do the cross multiplication to have 2 into y less 3 is equals to 7 into x less 0. If you expand, you will have 2y less 6 is 7x. Then you collect the like terms. Take negative 3 to the right hand side, you will have 2y is equals to 7x add 6. Then in the form y is equals to mx plus 2 plus c, divide by 2, so that this cancel out and y is 3.5x, you add 3. That becomes the equation of the line. And again, remember, you may be given the question with direction on what to do when it comes to writing the final equation. If you are taught to write in the form y is equals mx plus c, you have to ensure it is in the form y is equals mx plus c. If they change the form, maybe they want you to write in the form ax plus by is equals to c, again, maintain that, that way of writing the equation. But the whole thing is that when you're given 2 points on the line, to determine the gradient of the line, what you simply need to do is you find the gradient using the formula change in y over change in x. Once you obtain the gradient, take one of the given points and a general point xy, obtain the gradient expression, then equate the gradient you've already obtained using the given points, and then simplify by doing the cross multiplication. Then ensure you write the equation in the standard form, which is y is equals to mx plus c. So that is our part 1 of number 2. And so we go to number 2, part B. If you're not given 2 points on the line, then we may give you a case for now 1 point with a gradient. You may be told to determine the equation of the line given, that is case 2, we're now given 1 point on the line and the gradient. Given 1 point on the line and the gradient. So it's made simpler for you that the gradient has already been obtained. So work out from the given point. Simply take the given point. You simply use the given point and the general point xy, and obtain the gradient expression. Obtain the gradient expression. You equate the gradient expression, to the given gradient, and cross multiply to simplify. To simplify in the form y is equals mx plus c. You simplify in the form y is equals mx plus c. So let's see practically what we do for this case. You are told to find the equation. Find the equation of a line passing through -1, 7, and whose gradient is 1 over 4. So unlike the previous example, we were given 2 points, but here we've been given only 1 point. So we are saying you start from the given point and a general point xy to obtain now the gradient expression. So we'll use this point. We'll say we now use the point -1, 7 and xy. With these two, we'll say gradient is equals to the change in y over the change in x. This will give us y less 7 over x add 1. Why is it plus? Because it is x minus 1. So minus turns to positive, so we have x plus 1. And this gradient has already been given as 1 over 4. So we equate it to 1 over 4. And then do the cross multiplication so that we have 4 into y less 7 is equals to 1 into x add 1. Then by expansion, we have 4y less 28 is equals to x add 1. Then collect like terms. This turns to the right hand side. So 4y is equals to x add 29. In the form y is equals mx plus c, you divide by 4. So you divide this by 4, by 4, by 4. And so you have y is equals to x over 4. You add 7 and 2, that is 7 and 1 over 4. 7 and 1 over 4. So that becomes the equation. And as you can see in the equation, the gradient has already been factored out as 1 over 4, and then the y-intercept is 7 1/4. Number 2, what if we have this case? You're told, determine the equation of the line passing through we have the point 4 and 3 whose gradient is -2. Leave your answer in the form ax plus by is equals to c. So we leave the answer in the form ax plus by is equals to c. The procedure is still the same. Use the given point 43 and the general point xy. So you'll have this case solution. We use 4, 3 and x, y. With this gradient will be equal to change in y over change in x. And so we'll have a case for y less 3 over x less 4. And this gradient is equal to -2. And so any number is always over 1. We do the cross multiplication. And so you have y into y less 3 is equals to -2 into x less 4. Expand, so you have y less 3, -2x, add 8. So you collect the like terms. But we are told to give the answer in the form ax plus by. So I will take y to the other side and bring x on this side. So I will have -2x. Y crosses the other side, so we have -y. Then -8 crossing, we have -11. So that is the form. You can divide by negative so that you have 2x plus y is equals to 11. And that is the equation that you've been asked to give. So any of the two, either you're told to give in the form y is equals mx plus c, or you may be asked to give the equation in any form. Ensure you follow the instruction of the examiner to write the equation as you've been asked. So that is the second part of our number 2. And that is now what takes us to the last part of this topic, which is very important, and that is the application of gradients to pairs of parallel lines and pairs of perpendicular lines. I hope by now you understand what's a parallel line, or what are parallel lines, because that is covered from your primary mathematics up to Form 1 mathematics. So you should know what are parallel lines, and then you should know what are perpendicular lines. In brief, when talking about parallel lines, we are referring to those lines that do not meet. But they should not just meet. But they do not meet when drawn in the same dimensional plane. What I mean is, we have two different planes. We have the 3-dimensional plane, we have the 2-dimensional plane. If draw two lines in the 2-dimensional plane and they don't meet, then they are parallel. Again, if you draw lines in the 3-dimensional plane and they happen not to meet, they will still be parallel. Because there is a possibility of drawing a line in the 2-dimensional plane and the 3-dimensional plane that will end up meeting, and so we may not just really see them as parallel. So when you're explaining a parallel line or parallel lines, know that these are sets of lines that do not meet when drawn in the same dimensional plane. And so it could be the same 2-dimensional plane, or it could be in the dimensional plane. When talking about perpendicular lines, they are lines that meet at right angle. For parallel lines, this one, parallel lines, these lines do not meet when drawn in the same plane, same dimension plane. We usually draw them or represent them using arrows of this kind. So we find line A and B, this line A and this line B, they are parallel, they do not meet. Again, I can draw another pair of lines and use arrows again. These arrows are used to denote parallel lines. So those lines, however much you extend them or you produce them, they will still not meet because they have been drawn in the same two-dimensional plane. If you talk of perpendicular lines, then you should be remembering something called perpendicular bisector lines. Lines that divides a certain line into two equal parts. For two perpendicular lines, this one they meet at right angle. Perpendicular lines meet at right angle. So if I have this line and another line here, this is my line X, this is my line Y. X and Y meeting at 90 degrees. Then this line are perpendicular, sorry. Again, we can have this line. This is a straight line. If I draw a line of this kind, meeting at this 90 degrees, and this line P, line Q, then P and Q are perpendicular lines. So perpendicular lines meet at 90 degrees or at right angle. Parallel lines do not meet. That is the general understanding of the two kinds of lines. But what is very important in this part is to understand how a certain set of parallel lines are connected in terms of their gradients and how a certain set of lines are connected in terms of their gradient if they are perpendicular. That is the story that we want to make here briefly. Now for parallel lines, their gradients are equal. If, for example, this line A has the gradient M1 and this one has the gradient M2, if they are parallel, then M1 should be equal to M2. Again, if line C has the gradient M1 and this one has the gradient M2, this is simply the gradient. On top of M1, that is gradient. M2, again, that's gradient. Again, this is the gradient of this line. Then M1 has to be equal to M2 because the lines are parallel. So for a set of parallel lines, they will have the same gradients, and we shall use them to calculate our equations. For a set of perpendicular lines, if this one has the gradient M1 and this one has the gradient M2, then the product of their gradients should be equal to -1. That M1 times M2 should be equal to -1. If P has gradient 1 and Q has gradient 2, again, the product of their gradients, M1, M2, should be equal to -1. In short, they are simply reciprocals of each other. And so what we need to do is to remember these formulas. That whenever a question is talking about parallel lines, then know this is the relationship. Whenever a question is talking about perpendicular lines, know this is the relationship. That you multiply the two gradients, you will be able to get -1. I hope we are together up to that point. And so let's conclude this using questions and see how we apply. And you'll find that in most cases, questions will be asked from the application part. So let's see one of the questions. You are told to determine the equation of a line passing through 5, 2 and parallel to the line y is equals to a half quarter x minus 4. So the key thing here is that these lines are parallel. That is the key thing. They are parallel. So what we need to know, if they are parallel, we need to identify what's their gradient. And from the given equation y is equals to a quarter x less 4, we've said you can obtain the gradient of the line given the equation by simply picking out the coefficient of x, as long as the equation is in the form y is equals mx plus c. So in this case, it is already in the form y is equals mx plus c. So the coefficient of x here is a quarter, implying that the gradient, which is m1, is a quarter. And because these are two lines that are parallel, then they have to obey or to go in line with this principle. That because they are parallel, since they are parallel, then we are saying m1 has to be equal to m2. And so that m2 is a quarter again. And then this takes us back to this part. How do you determine the equation given one point and the gradient of the line? Because this is the gradient and this is the given point. So we have said we use the given point 5, 2 and a general point xy. Then we obtain the equation that is y less 2 over x less 5 and equate it to 1 over 4. We do the cross multiplication, and so we have 4 into y less 2 is equals to 1 into x less 5. By expansion, that is 4y less 8, x less 5. We take negative 8 to the right side. We have 4y is equals to x. Negative 5 plus 8, that gives us positive 3. So we divide by 4, y becomes x over 4 plus 3 over 4. So that is the equation of that line. Again, you will see in this equation, the gradient is a quarter. The gradient here is a quarter. So that is how we apply the two given parallel lines. Given now perpendicular lines, you can have a question. Determine the equation of a line passing through -1, 3 and perpendicular to the line whose equation is 3x plus 4 is equals to 5y. We've rearranged the equation. So what you need to do, again, start from the given equation and obtain the gradient. So from the equation, 3x plus 4 is equals to 5y. We'll divide by 5, so that this cancels out. So it means y is equals to 3 over 5 of x, add 4 over 5. So what's the gradient? The gradient is 3 over 5. Our gradient here, which is now our m1, is 3 over 5. And the key thing in this statement is that these sets of lines are perpendicular. And because they are perpendicular, then since they are perpendicular, then we are applying the relation that m1 times m2 will give us -1. So what is our m1? That is 3 over 5 times m2 should be able to give us -1. How do you get m2? Multiply by 5 over 3, multiply by 5 over 3. So this cancel out, and so our m2 becomes -5 over 3. This will be -1 and 2 over 3. That is how we will obtain the gradient for the second line, which is a perpendicular line. And so we need the equation, not the gradient. And so we go back to this point. We use the point -1, 3 and xy. With these two, y less 3 over x add 1 should be able to give us -5 over 3, which is the gradient here. Do the cross multiplication to have 3 into y less 3 is equals to -5 into x add 1. If you expand, you will have 3y less 9 is equals to -5x add 5. Sorry, subtract 5. We subtract 5. Then we collect the like terms, -9 to the right side. Therefore, 3y is equals to -5x. Then we add 4 over 3 over 3 over 3. This cancel out. So y will be -1 and 2 over 3 of x. We add 1 and a third. That is the equation. So we've obtained the equation of a set of perpendicular lines and a set of parallel lines. The logic there is simple, that if two lines are parallel, then they will have the same gradient. If two lines are perpendicular, then the product of their gradients is -1. So finally, we can now have a question of this kind. A straight line passing through -1, 2 and 4, 6 is perpendicular to a line x, whose equation is y is equals to -2x plus 5. It's perpendicular to the line y is equals to at the point P, -1, 2. So you will see in the way this question has been structured that you've been given 2 points. Now, not the gradient, but you've been given 2 points. You've been given 2 points of a line that is perpendicular. This is the equation whose perpendicular to a line x that is passing through x and the point P, which is -1, 2. Sorry for that. Passing through the point P, -1, 2. So I was saying you've been given 2 points, -1, 2 and 4, 6. And that line is perpendicular to a line x. that is passing through the point negative 1, 2. And then the question is, we find the equation of x in the form y is equals mx plus c. So one thing, we'll start with these given points, the two given points, which is the point P, negative 1, 2, and the other point 4, 6. So that from these 2 points, we can be able to obtain the gradient, which is the change in y over the change in x. And so we'll take 6 minus 2 over 4 minus 1. That will give us 4 over 5. That is the gradient given the 2 points, P and the point 4, 6. Now, because they are perpendicular, again, we'll say, since they are perpendicular, then m1 times m2 is equals to negative 1. So we take 4 over 5 m2 equal to negative 1 times 5 over 4 times 5 over 4. This cancel. So m2 negative 5 over 4 as our gradient 2. Then this line is passing through the point P. So we'll use the point P, which is negative 1, 2, and xy. So we'll have y less 2, x add 1 equal to negative 5 over 4. Then we do cross multiplication to have 4 into y less 2, negative 5 into x add 1. Simplify this to have 4y less 8, negative 5x, negative 5. Then take negative x to this side, you 4y is equals to negative 5x, then plus 3 over 4 over 4 over 4. And so y is equals to negative 5 over 4x plus 3 over 4. 5 over 4 is an improper fraction, so what you simply do, this now means y is equals to negative 1 and 1 over 4x, add 3 over 4, and that becomes the equation of the line x in the form y is equals to mx plus c. Good. So that is where we end our summary for the topic gradient and equations of straight lines. And I believe with the 3 parts that we've highlighted, you've been able to follow through the whole topic, and you can now do more practice and more revision on the topic gradient and equations of straight lines. But just as you continue revising on this topic, I will ask you also to look at a series of questions that involve quadrilaterals, especially the rhombus, the rectangle, and the square that have the equations of lines. Maybe you are given a rectangle and you are asked to determine the equation of the one of the sides and the points on either, that is either side of the rectangle, and so on. So revise based on the 3 aspects that we've looked at, and it shall be well in this topic, gradient and equations of straight lines. It has been my pleasure being with you today. I'm your teacher, Mr. Ndenga-Global. I wish you a nice day. Thank you.